We are now 2 years and 8 months into the Crash Team Racing Decompile effort. My name is Niko, I am the lead of the project. I am in VR now, in case you haven't noticed. And I'm going to give this video to Darkgazer to upload to his channel. If you are a programmer, this video is going to explain all of the newest research, how it all works. If you are not a programmer, all you need to know is the most recent research is getting us closer to custom levels, it's getting us closer to better mod stability, and basically if you don't see new mods for the next few weeks or so, it is because we're figuring out this and trying to get a PC port done. So since the last Decompile update, we are now at 97% with figuring out how it all works, and we are at 9% for rewriting the code, and when that rewrite gets to 100, we have a PC port. So in the last video, we discussed how there's now a GitHub repository which holds all of our decompile, all of our rebuild, all of our mods, and we also have these lectures right in the root of the repository, 4 links, and that explains the most basic parts of the CTR code, which I'm not going to recap all of, but you just need to know that there are speaker notes in the sections that explain what's going on in each slide. And if you're all caught up with those and you know how instances, threads, objects, level instances, and non-level instances work, then this video is for you. So, the most recent discoveries were the last of the quad block structure, which shows how all of these quad blocks all around the world, if I click on here, so all of the quad blocks do not have normal vectors baked into them. We thought there were, and there aren't. They're doing cross product for that, and this is just making the normalization math faster. After that, we did a lot of research on the BSP tree, and we found hitbox collision for all of the level instances that do not move. The seals move, so they don't have this. The TNTs, nitros are not level instances because they're placed by players, etc. So anything with a green box is going to use this system down here for metal data models. Now, when we gave these other presentations, we did not critique the code. There was nothing we particularly wanted different. This system does not exactly work, so we're going to go over what Naughty Dog wanted it to be, what it ended up being, and how we're going to improve it. So this green box means that is part of the system, and the Wumpa Fruit, the Wumpa Fruit box are all going to take advantage of this. So we have 2 function pointers for every level instance. We have level func instance birth and level thread birth. So we have a generic level instance birth here, which is used by the weapon box, the Wumpa box, etc. And basically what this does is it checks with the BSP tree to see, does this instance touch a reflective quad block like ice on Polar Pass? And if it does, then the instance is made reflective. So for all other instances, like the fruit here, the Wumpa Fruit, which is over, click on here, click. So this one, for example, won't have the same, but it calls the default, and every single level instance birth calls a default and then triggers some other variables. So that's fine, there's nothing broken there. The thread birth system is a problem, because when you have the weapon boxes, they need a thread, and the Wumpa box needs a thread. Other things like this Wumpa Fruit or the crystals in Crystal Challenge, they don't need thread birth, because there either already is a thread or a thread isn't needed, and yet every single one is birthing a thread, so there's some redundancy. So here's exactly how that works. When you break a weapon box, for example, you have the crate weapon thread birth, and basically it checks, is there already a thread? If not, create one, give it the object, the instance, and an on collide. Now this is the first part of redundancy. You don't need on collide if there's already a collision here. So basically it sets the function pointer, and right after that it executes it. So there's never not going to be an on collide because it was just set. And when you have the on collide down here, it takes the object, it takes the instance, which you already had up there, and then basically if this is not the first frame, then basically do nothing, and if this is the first frame of the collision, then set a 30 frame timer, which is 1 second, and then it triggers an explosion because it's the first frame for the crate to break, so on and so on. Set the position of the explosion, create a sound, simple stuff. But that didn't need to go on collide, that could have gone up here. And then while this thread is alive, you have the crate per frame, which is basically checking as soon as the timer is done, then make the crate grow back. This is how, after it's gone, it goes boop, and it grows back. And once the thread has finished growing the crate back, the thread does not stay alive. The thread dies right here. So the point of this system is to keep the thread pool empty, because these instances don't need threads constantly. When the collision happens, it starts a thread, and when the weapon box is back, the thread is dead. This is the least redundant use of the system, and we can tell by looking at betas that this was the first time the system was used. It was originally a time when there were only the weapon boxes and the Wumpa boxes. And then there come the Wumpa fruit on the track, which becomes more redundant, because up here we have the thread birth function. So similar to before, if there's no thread, then make a thread, and then set an onCollide, and the onCollide is executed. That's the same redundancy as before. But when we have onCollide for the fruit, which one was it here? That was that one, that was this one. Oh, I have to scroll up for this one. So up here is the fruit onCollide, which basically takes the 3D position, turns it into a 2D position, and it starts the UI transition where it goes from the track to the corner of your screen. Now, that doesn't need a thread. There's an independent system that can run that in the background, but on top of that, the thread is killed immediately. So it births a thread just to execute this immediately, and then kill it immediately. And then on top of that, there is also a per frame, which also kills the thread, so that is redundant. But also, all of these thread emitters executing the per frame function pointers, which are down here, part of the thread, they also had this infinite loop system, and this was part of the most recent research, because we spent the entire Decompile effort looking at this and not knowing what it does. So, all of these are going to return to the same return address. They didn't want to store the return address on stack, then get it back on stack, and then jump to register return address. That's slow. So by causing this infinite loop, they are basically making it so the return address is not saved, and then by calling this function, which is not even a real function, that is the return address it's returning to. So this is basically a more optimized version of returning, and we probably won't use that for the rebuild because with modern compilers it might not work, but also this is only saving like 3-4 instructions. We could probably save more instructions by first of all getting rid of the thread redundancy, and also just using a more modern compiler with better compiler optimization. So on top of all that, we have the thread birth causing redundancy, onCollide being called for level instances. So how we are going to change this is we are going to make it so that function onCollide is only for non-level instances, and the level instances are just going to use the thread birth, not for birthing a thread, but instead for just being renamed to level action. And by renaming it to level action, stuff like the fruit are not going to spawn a thread at all. They're just going to trigger the UI and then make itself invisible. The crystal challenge, for example, if I go over to crystal challenge, different level, load level, this has a different type of redundancy. If we go to Nitrocord, why not? Okay. So you'll notice that the crystal has the thread birth and the instance birth, and the TNTs and nitros don't. Even though they're technically part of the level, they still don't. So when we have the crystal, let's go quickly to Control F, take that, drag it over here, crystal, init, and when we find that, we'll see, or on init it was called. Oh no, I called it LINB. Okay, so remember how the instance birth is not actually supposed to start a thread. The point is that the weapon box, mappa box don't have threads in use. We're trying to reduce the thread pool. But remember, the crystal needs to spin. So we end up creating a thread here anyway, and then starting the crystal spinning, doing specular stuff, and then calling the default linb for checking for reflectivity. But then, when we actually collide with this crystal, and we call function level threads birth, which should be up here, we have the same copy-pasted code of checking if a thread does not exist and then birthing a thread, which is not needed. That is also redundant. And then it does the same thing with calling func on collide, when it could have just done the collision code right here. So basically we're going to, even though we're certain Naughty Dog called this LevelBirth, we don't have 100% proof they called it level thread birth, but they probably did because they're all birthing threads. We're going to rename that to level action, and then remove all the redundancy and just have the action happen during the collision, unless it is one of those boxes, the Wampa box, the question mark box, where it really needs a thread. And you'll also notice that these nitros are not part of the BSP. This is because the Crystal Challenge was one of the last modes to actually be built, and this was actually something that stumped us for a while. Every single nitro and TNT is checking for collision with every driver, every frame. So in most races, it's not a problem because there are 7 crates and 8 drivers. In this one, in Crystal Challenge, there's like 40 different objects that are all checking for collision, but it wasn't a bottleneck, so they didn't need to change it, and we probably won't change it either. But trying to figure out, could the BSP refit? Could you add things to the BSP or not? And the answer is simply no, it doesn't. So by figuring out how to replicate these hitbox objects for the instances, now with the progress towards custom levels, we know how to properly make the instances with their hitboxes. We also now know, I forget if I brought it up in the recording yet, the way the normal vectors for collisions are found from all of the quad blocks. That is in the quad block footer here. This is actually not a normal vector encoded. The normal vector is found with a cross product, and then this is just for normalizing the normal. So now that we know that that is basically a fast math optimization of magnitude, we haven't replicated it yet, but we are very much working on it. Let's see my notes. Is there anything I forgot to mention? Explain the infinite loop, explain LINB, all thread birth, and that. Oh, so coming up next in the rewrite effort, we do have enough research to rewrite the entire 231 overlay, which was the largest overlay in overlay slot 3. So if you look at the presentations on how the stack allocator works, that comes after the overlays. So when we rewrite 231 and we don't have the redundancy, that's less RAM for the overlay, which means we can move the entire stack allocator back in RAM, which means we have more memory for Oxide, and potentially we'll be able to move Oxide out of kernel memory and just put it on the heap, which means that Uniram will not break, PSIO will not break, and the textures used for retrofuels, they live in kernel. You might notice if you combine Oxide fix with retrofuel, the custom textures are gone. That's all going to be fixed once we get that rewritten. And also in the effort of rewriting the game, if I go to, where's my mouse here? Giant monitor, where's my mouse here? If we go over to the Explorer and we go back to Crash Team Racing and Decompile, General, we have a lot of the game rewritten. And a lot of the time we rewrite the game, we make functions smaller and then we're able to put that back into the memory allocated for Oxide. So at the same time, we are rewriting more of this, making it so that we are not only closer to the PC port, but every time we rewrite the functions, we are putting them back into mods. So mods will co-evolve with Decompile, and everything is a work in progress. So we're still trying to keep videos every 1 to 2 weeks. If we go a little while without it, it's because we're trying to get all this done for the PC port. And this video was not sponsored by VR. I just don't want to use the monitors anymore. If you do want to use this software, it is called Immersed. It's on the Quest store. It is free. This one. And you probably cannot see it, but there's a pass-through mode, so I can actually see the room around me. I can see my keyboard, I can see my mouse, controller. I can see my cat over there, even though you probably can't see it. This is the software if you want to use it. So, thank you very much for watching. See you all in the next video.